one thing that an APU has in its control system is that it always runs at a particular speed. And once it's started, it will run at that speed regardless of the load on the engine. And the reason this is one of the purposes of the APU is to drive the generators. So okay, so we have a turbine here, and that's going through a gearbox then onto the generator. And aircraft traditionally would supply their air-sea power at 115 volts, 400 hertz. So to keep the frequency constant at 400 hertz, the APU ran at a particular RPM. So whatever that rated speed was, you kept it at that speed just to ensure we have 400 hertz coming out on the generator. But with more modern aircraft, such as the Boeing 787, the electrical system is frequency wild, so it's not as big as consideration. But traditionally, this is what happened. You had 400 hertz electrical signal. So this is the three phases. Now the electrical supply has preference. So if the engine is rotating, and let's say there is a draw on it from the pneumatic system. So the pneumatic system is, we're taking air from the load compressor here onto the pneumatic system. So if there's more work to be done, then the engine might tend to slow down. So what the FADEC could do is just pump more fuel in so that we keep the RPM constant. We could get to a stage though that the fuel valve is fully open, and we just can't put any more fuel in, or we have reached the maximum EGT. So if that happens, we can't put in any more fuel, or we've reached max EGT, and the RPMs begin to drop off. Well, what the FADEC will do then is it will cut out the pneumatic bleed. Okay, so the electrical system has preference. It will reduce this pneumatic feed so that the load drops off and we can retain this 400 hertz.